Alright, so we will continue to look at the TVA diagram. We dig a little bit deeper each time. Last time we look at those three different phases, and we look at their T, temperature, and also their specific volume. How is that different? You know, if we find out the temperature is less than Tsat, we know immediately that's going to be compressed liquid, right? If we know their specific volume is greater than Vg, then we immediately know that's the superheated vapor. That's how this criteria will help us later on. And however, we're going to add a little bit more to this list. So if we learn about internal energy, right? We're also going to use enthalpy, H, and we're also going to use entropy, S. So if we define UF, we know what is that. That's going to be specific, which is intensive property, right? Specific internal energy at what? Saturated liquid. So in that situation, we also can write down HF. That's going to be specific enthalpy at saturated liquid. If we write SF, that's going to be specific entropy at saturated liquid. Then we can further define the next set, which is UG, HG, and SG. Those are just at saturated vapor. So thinking about this, you know, from solid to liquid to gas, what happens? They have more and more energy, right? They're going to have more and more internal energy, more enthalpy, H, more entropy, S. So here, if we're going to have a column for U, we're going to have a column for H, we're going to have a column for our S, entropy. How do we define for the phase number 1, compressed liquid? Our internal energy is going to be less than the internal energy at saturated liquid. If it's less than that, it's going to be for sure compressed liquid. So same thing, H is less. If the enthalpy is less than enthalpy at just saturated liquid, now we know for sure it's going to be compressed liquid. Same was here. So here we're adding more information. If it's mixture, what do we know? This is specific internal energy is going to be between UF and UG. Just like it is for V, specific volume is between VF and VG. So if this internal energy is greater than UF, however less than UG, then we know for sure it's a mixture. Same thing here. H is greater than HF and HG. S greater than SF, less than SG. Alright. Now how about the last region? If it's a superheated vapor, we know the internal energy. It's even going to be greater than the saturated state. Same thing for H. It's going to be greater than specific enthalpy at saturated liquid, saturated vapor, Hg. This is going to be greater than Sg. The way, yeah. So I think this table will be quite comprehensive, help us determine what phase that is. But now there's one more point I want to touch on in this video, is further define this region, our saturated liquid vapor mixture. For this region, we know there's a quality. If there's a quality, we know it's a mixture. Now we're going to look at this quality. Quality, we said earlier, it's mass of the vapor over the total mass, right? Mass of the total. The total will have liquid and a vapor together. And we know x equal to 0 when it is completely liquid, saturated liquid. X equal to 1 when it's completely saturated vapor. Liquid completely converted to vapor. Now, if, for example, we know x ranges from 0 to 1. If we know the quality, can we find out some specific property, like, for example, our V, specific volume? Here's a formula. V is going to be, if this V for saturated mixture, liquid, vapor, mixture, then this V is going to use in this formula. So this is only for this region. That's going to be equal to VF. We know this V is going to be in between VF and VG, right? And then if we want to find this V value, it's going to be VF plus quality times VG minus VF. The difference between the specific volume and then times quality, then plus VF. That's going to be the specific volume at that point based on the quality at that point. And very helpful and very useful equation. And this equation can be further expanded for other property like enthalpy H. That's going to be equal to HF plus X Hg minus HF. And here Vg minus Vf, also people write as VFG. VFG, it means the difference between VF and VG is VG minus VF. Same thing, Hg minus HF we can write down as HFG. Okay. Then the next we can further extrapolate as our internal energy, specific internal energy. It's going to be equal to UF and times X quality UG minus UF. Of course, you know, that can be also considered writing down as UFG. Okay. And I'm going to write one last one. I believe it's entropy. That's going to be SF plus X SG minus SF. Well, needless to say, that's going to be the same. So those are very important equations, completely used, only used for saturated liquid vapor mixture. Okay, those equations going to use quite a bit for the future study. And that's all for this video. All right, bye.